Thanks very much. I'm Kirk Johnson. I'm the director of the Smithsonian's National Museum of Natural History, and it's my tremendous pleasure to be in conversation with Ed Yong, who has written yet another amazing book about natural history. I had the pleasure to chat with Ed a couple of years ago when his book, I Contain Multitudes, came out, and this whole story about all the other things that are part of our bodies really kind of blew a lot of minds. And reading this book to me was great because what it did was it brought together probably 1,000 anecdotes I've encountered in my life and made some sense. And amazingly enough, he was able to summarize it in one single word, a word I'd never heard before. It's sort of the word of the book. You know the word I'm talking about.
That's right, it's Umwelt.
Umwelt. I didn't know how to pronounce it. That's why I logged you into that.
I only just about know, so if there are any native German speakers in this room, I apologize profusely.
So talk a little bit about Umwelt.
Right. So it comes from the German word for environment, but it's used by biologists not to mean the physical environment, not say the table or the chair over here, but the sensory environment, the specific set of sights and smells and textures and sounds that every living creature is privy to, but that may well be unique to it. So the human Umwelt includes a large number of textures that I can feel with my very sensitive fingertips. It includes colors ranging from red to violet. It doesn't include ultraviolet, a color that actually most sighted animals can see, but that we humans can't perceive. It doesn't include the magnetic field of the Earth that a migrating robin or a swimming sea turtle can sense, but that I cannot. So each creature has its own unique sensory bubble, its unique slice of the fullness of reality that it can perceive. And that's what the Umwelt is. It is a term that I think is at once incredibly humbling, but also beautifully expansive. You know, it's humbling because it tells us that despite the fact that I'm sitting here with a sense that my perception of the world is complete, and they're not glaring holes in my perception that I'm thinking about all the time, and yet those holes are there. You know, there's so much that I'm not getting, but it's also expansive because it shows us how wide the world truly is, and I think it tells us that to really appreciate the fullness of reality, we need to think about the experiences and the senses of our fellow animals.
You know, as I was reading the book, I thought about that a lot, and I was overcoming my insecurity of not having a large enough Umwelt.
Right.
You think, I can't see those colors. What's that new purple I don't know about?
That's right.
But
Umwelt envy, it's a new problem.
it's right. I'll leave with a crushed Umwelt. The thing that really jumped out at me, though, is the fact that I love the natural world, all the animals, the plants, the insects, everything. I'm intimately fascinated. I run the Natural History Museum, where I have the #1 key, which lets me look at 147 million different individual examples of the beauty of the natural world. And it didn't really occur to me until I read the book that when I look at an organism, I'm seeing the manifestation of its Umwelt. Like, there's some funny feature in an animal. It's probably because evolution honed it towards what it looks like.
Yeah.
So you're seeing these things, and maybe you can give a few examples of your favorite Umwelt expressions in the physical bodies of organisms.
Yeah, so so I love this question, and actually some of my favorite examples are things that we can't perceive. You know, so there are, so a lot of flowers, for example, have bright, vivid markings in ultraviolet that we can't detect. And so a sunflower looks plain yellow to us, but actually has a vivid ultraviolet bullseye at the center of it that bees and other pollinating insects can see. A lot of flowers are like this. And actually, if you look at all the flowers that exist in all their varied and wondrous colors, and you ask, what kind of animal eye is best at discriminating these different colors? The answer is not a human eye. It's actually the eye of something very much like a bee. that, like us, has 3 kinds of color sensing cells, but while ours do red, green, and blue, a bee's does green, blue, and ultraviolet. And with that eye, you become very, very good at telling the colors of flowers apart. So the colors of flowers, even though we might adore and be fascinated by them, did not evolve to delight human eyes. They evolved to ideally tickle the eyes of bees. And it is that way round, because the bees came first and flowers evolved later. It wasn't that bee eyes evolved to best perceive flowers. It was that flowers did that to attract, that flowers evolve their colors based on the eyes of the pollinating insects that were already around. And that's amazing to me, because it suggests that, you know, we talk about beauty being in the eye of the beholder. It also arises because of that eye. The senses feel like these passive intake valves. You know, I'm sitting here, sound is coming into my ears, light is coming into my eyes, but actually the senses play an incredibly active role in shaping the world around us. Just by dint of seeing and hearing, animals change the nature of colors and patterns and songs.
So in a way, what that means is it kind of gives you another way to visualize how evolution happens as well, in a very reverse kind of way, because I think people have a sense that evolution happens because of random events, but in ways, the actual seeing adds another component to that, which I never even thought about it in that sense, and it was very compelling to me. If I was sitting next to a tarsier and it was yelling at me, what would it sound like?
It would sound like nothing, because so a tarsier is a small primate that kind of looks like, do you remember that film Gremlins? The little mogwai, those little fuzzy things, that's what a tarsier looks like. It is one of many animals that produces ultrasonic calls, too high-pitched for humans to hear. And a lot of people have discovered animals that have ultrasonic calls because they're opening their mouths and they look like they're screaming, but no sound is coming out. This is the case for hummingbirds, for tarsiers, and also for mice and rats. You know, most of you probably have never heard of a tarsier before, but you know what a mouse or a rat is. They've been mainstays of laboratory research for, I don't know, centuries. And yet, it wasn't until in the middle of the last century that people realized that these very familiar animals were producing sounds that we can't hear. And until actually quite recently that we understood how complex those sounds can be. So courting rodents will duet with each other ultrasonically. If you tickle a rat, it will make kind of like ultrasonic laughs. Like it will kind of giggle. And I think that's a wonderful example of how there's this entire world, even in the most familiar animals, of information that we are not privy to, but that, you know, is fundamental to their lives.
So it kind of brings to mind the ultimate, like thousands of possible new New Yorker cartoons can emerge from this situation.
Right.
But you work with scientists, or you've interviewed scientists who have tools to make these sounds audible. I was particularly entranced by the idea of people walking around with special microphones and recording what insects were, the sounds insects were making.
Yeah, I'm glad you talked about this, because I love this too. I met a guy called Rex Cockcroft who studies leafhoppers. They're small insects that live on plants and that drink the sap of plants. Leafhoppers will vibrate their abdomens and send vibrations up through the stems and the leaves of plants that can get picked up by other leafhoppers standing upon them. These are not classic sounds as we classically know them. They're not audible. Even if you're standing next to the plant and listening out, you probably can't hear them. But you can clip a microphone onto the plant and convert those vibrations into audible sounds. And when you do that, and Rex does this a lot in his own garden, in parks, wherever he goes, what you hear are sounds completely unlike what you would imagine an insect would produce. They are not the simple chirps of crickets or cicadas. They are haunting and melodic and often beautiful and very eerie. They can sound like musical instruments or hooting monkeys or birds or machinery. They're very, very strange. And the idea to me that the plants around us, in every garden, in every park, are just thrumming with these vibrational signals, these vibrational songs, that even if we put our ear to them, we couldn't hear, is astonishing. I went out with Rex to his local park, and he just clipped a random, after like half an hour, we just heard coming out from his amplifier this sound that sounded, I don't know, it was almost like a fairy hyena. It was like, it was a very small thing going, and I asked him, have you ever heard that before? And he went, well, the thing is, so few people do this or even understand that this world exists, that there's a very strong chance that if you do it, you will hear a sound that no one has ever heard before. And that's incredible to me. That sort of speaks to the subtitle of the book, that the senses of animals reveal to us all of these hidden realms all around us.
No, it's so great, because I often tell visitors to the museum that they're as close to infinity as they're ever going to get, because we have all the remains of the biological world, but of course, most of the animals we have in the museum are deceased, and their behaviors are deceased with them. So these talk about infinity times infinity in terms of what you might encounter with 2 million species of life that we know about out there. All of them living in their own umwelts and inaccessible, unless you go through the portal which you've discovered, which is the portal of obsessed scientists.
Yes, yeah. Yeah, the scientists in the book are really important, right? I think they act as like gateway characters. They show people who haven't been thinking about the Umwelt concept, what it is like to be obsessed by it, to really spend a lot of time thinking about what an electric fish senses when it sends electric pulses into the water, what a spider feels when a fly lands on its web. And I think that much is in the first book I wrote, where the scientists who are obsessed with microbes give people a sort of very obvious character. Like, if you think that something is gross or uninteresting, one really great gateway into it is to learn about people who care about it. Now I have to do less work there in writing about the sensory worlds of other animals. Like, if I'm writing about my dog, I don't need to make special effort to tell people dogs are great. But I do when it comes to things like spiders, snakes, scorpions, sharks, bats. Many animals that I think a lot of people are put off by have incredible sensory abilities and feature very heavily in the book. In the chapter on vibrations, in a section about spiders, I meet a woman named Beth Mortimer, who studies spiders in England. And I met up with her and asked her to show me her spiders. And I thought that she would take me to a small room in which there would be like some glass cages and there would be some spiders in there. But instead, we walked into this quite sizable hangar-like space in which were many free-range spiders about the size of my ear, with like meter-wide webs, and also flies buzzing around, because how do you feed free-range spiders? You just have a ton of flies flying freely around the room. They're landing on my hair and my notepad and my recorder. And she is in heaven. She loves it. And I think that's delightful and charming. Like, I think it shows people that even in corners of nature that I think most of us would find off-putting, there's wonders and magic to be had.
And many of those corners actually exist in the Natural History Museum. I have a parasite expert who has invited me several times to go collecting leeches with her, which involves wading into a pond until the leeches fix themselves.
Is this Anna?
Yes.
Yes.
I have not accepted said invitation at this point in time.
So she gave me a tour of your parasite collection for a piece that I wrote in The Atlantic called "Washington, D.C. is home to the nation's largest collection of parasites." Every story is a metaphor.
That's right. It's the rare double entendre that's true at both ends.
Yeah, that's right. Not that way, but also yes, that way.
So this, I do curious, because like you talk to a lot of scientists in writing this book. I was really impressed that you're thoroughness in finding your way to the various little caverns where they kept their spiders or their bats or their whales or whatever they were. But two things about this. One is, I think it's interesting that you collect scientists, and I'm curious what you do with them when you have them, because you have a small relationship now with a number of scientists.
Right.
And I'm curious if you do this book and you have those relationships and you move on, or do you actually have a growing cadre of scientists who you interact with on a variety of reasons, or are you kind of a one and done as you extract their umwelt and move on?
Wow, this makes it feel so much more parasitic than I used to think about it. I think that there are some people who I'm continually delighted by, but you know, it's so a couple of things. I write about a lot of different topics, and I do try and make sure that I'm continually finding new people to talk about with every new story. Like even my pandemic reporting, every story, at least half of the sources are people who are new. I think that's really good. I think it exposes you to new ideas, a more diverse pool of sources. And I think as a journalist, I do feel the need to maintain a certain amount of distance from the people I talk to. You know, I'm not cheerleading for science. I'm also meant to be acting as a watchdog for it when necessary. And you know, and in an immense world, a book largely about like positive things, that doesn't come into play so much. But also it does a little bit. You know, there's a whole chapter about magnetoreception, so the ability to sense the Earth's magnetic field, an ability that songbirds have, that sea turtles have, that many animals probably have. This is a highly controversial area for a number of different reasons. It's very difficult to study magnetic fields. They're very counterintuitive. No one knows what the organ is that detects those fields, because those fields permeate living tissues. The organ doesn't have to be an eye or an ear. It doesn't have to be on the surface. It could be in my thigh. It could be in my armpit. It could be anywhere. I do not have a magnetoreceptor in my armpit. I just
I do.
want to clarify that. Dear C-SPAN viewers, it's not. But so it's hard to study. It's also for that reason, it also becomes incredibly compelling, right? People want to be the first to find the sense organ, find that receptor. You know, there's talk of like the person who just solves this will get a Nobel Prize, right? This is the last truly unknown sense. And as a result, there's a lot of shoddy work published about it, a lot of things that get retracted like a few years later, things that don't add up. You know, people have terrible anecdotes of like being shouted down in the middle of conferences. So this story is not just a story about animals, it's a story about science as an enterprise, as a social process. Is something that is done by people and is subject to all the foibles that people have, like, you know, ego, power, money, all of that. And I think that's part of the book too. You know, the way in which the sausage gets made, the way in which we know the things we know, I think is a vital part of any science story. And I think to tell that piece well, you do have to be a little bit distanced from the people who you're talking to.
Yeah, fair enough. And it's interesting because there are so many scientists now. I mean, there's what, like 10 million scientists in the world, and the word itself was only invented in 1829. So
Right, yeah.
There was a time when there were 10 of them, and now there's 10 million of them. And one of the things that's interesting about that is they get more and more focused in their knowledge. And they get very divided. So one of the nice services the book provides is a sort of a broad, field-wide survey, really, of the different senses and who's working on it. And I would, as we were talking about before, I think you're right that people who are in the book will learn a lot about their field by reading your book, even though you're a journalist and they're the scientist, because you're giving them this broad view of an area where they've tunneled in very deeply.
Yeah, and I think two things on that. Firstly, I hope that the book will be useful to even people who study the senses of other animals, because as you say, a lot of them focus on one thing. There are people who study vision, or people who study sound, people who study magnetoreception, and this book is an attempt to synthesize all of that and actually draw threads between the different senses. I actually had, like, one of my moments when I thought I've actually done a good job with this was when a scientist named Eric Warrant, who literally wrote a textbook on animal vision, had a look at the vision chapter and pointed at one footnote and went, "I don't think that's right." And I said, "No, Eric, I can show you like the reference for this fact." And he looked at it and went, "Ah, I've actually learned something new from this." So that was reassuring. But I think my other point is that in the Chronicles of Human History, the use of scientist is relatively young. But I think in that Western conception of it, right, as a profession, I think like the act of observing and making sense of the natural world is, you know, old and has been going on since time immemorial. And that's part of what I encourage people to do through the book. You know, I want people to be curious. I want them to extend the full force of their empathy to the lives of other creatures around them. You know, I want dog owners to be thinking about what their dog is doing when on a walk. I want people to think about what that spider in the corner of their bedroom is feeling through its web instead of simply brushing its web away. I want to inspire that sense of curiosity about the world because I think that it is full of endless wonders. You know, I give this example a lot, but like on every walk around my neighborhood, I will always tend to see the same animals, right? So there's always going to be pigeons, sparrows, starlings. And they seem boring and trivial, but they're spectacular. Each of those birds can see behind its head, which I cannot do. So their experience of the visual world is the world moving towards them, like mine is, but also moving away from them, which I can't imagine. They can see an entire dimension of colors that I do not have access to, and also cannot imagine. They can hear qualities in their own songs that fly by too quickly for my much slower ears to hear. So, you know, in the sort of baseline existence, some of the most obvious and familiar creatures around us are also magnificent. And, you know, I hope that that's something that readers of the book will take away with them.
You know, I think I really admire your desire to make that one of the outcomes of this book. And I think you're such a good and compelling writer that you're going to be successful. And I sort of take you as an ally of the Natural History Museum is how do you grow the curiosity in the natural world. And I will take this moment as an aside to say that Ed, the writer, has a dog named Typo, which I just love.
He's typography when he's being bad.
So you jumped from the obvious senses of sight and sound to the magnetic zone at the very end, there's semi-penultimate chapter. But the echolocation thing, this guy, what's his name,
Daniel Kish.
Daniel Kish, who was not born blind, but became blind very early in his life, has learned how to click and echolocate himself. That to me was fascinating to think that here's a human who is actually invading the umwelt of other animals.
Yeah, and this is fascinating. So Daniel is an echolocator. So he makes loud clicks with his tongue, and he uses that to perceive the world around him. I've gone on walks with him where he's using a cane, and he's getting tactile information in the usual way, but he's also clicking, and he can sense, like, when there's a tree branch across his path, when he's walking by a lawn or a house or a fence. He's remarkably independent, and his echolocation is part of that. A lot of people don't know, most people I think don't know that humans can echolocate, including a lot of scientists who study echolocation. But actually, if you look back at like the very first paper in 1944, where Donald Griffin coined the term echolocation, that paper is about bats and humans. This idea of human echolocators has been around for a long time, and certainly the people who've done it, you know, are aware that they're doing something, even if they're not branding it with this term. So I guess there's a bunch of things that that section does. Like, I think it establishes that even within a species, there's a huge amount of variation. You know, I say early on that An Immense World is not a book about superiority, it's about diversity. And I think that even with, you know, within the human Umwelt, there is not just one, there's a wide variety of them. I think it is really interesting because Daniel can give voice to certain things that, like, bat or dolphin researchers will say about echolocation that he also experiences. So echolocation is an incredible skill. If we turned off all the lights in this room, a bat could still snatch a moth that was flying around simply by making these high-pitched calls and listening out from the resounding echoes. It's amazing in the dark. What it's very bad at is finding small objects against a large background. So a bat will struggle, most bats will struggle to find an insect perched on a leaf because the large echoes coming back from the leaf drown out the much smaller echoes coming from the target. Similarly, Daniel's often asked to do party tricks where he's like, can you echolocate like the water bottle on this table? And that's really hard. So he can give voice to like these really interesting commonalities between this skill in him and other animals. But the thing that really fascinates me is that even though we have the same we have something in common, language, and the same language, I still don't know really what he experiences when he echolocates. Because even though he lost his sight from close to birth, he lives in a culture full of sighted people using sighted language, and his language has been influenced by that. So he will describe his echolocation in terms using visual terminology. He will talk about flashes or brightness, and I don't know whether to him those mean the same thing as they do to me. The American philosopher Thomas Nagel wrote this classic essay, What's It Like to Be a Bat?, where he argued that the subjective world of another creature like a bat, because of echolocation, is fundamentally inaccessible to us. Like, we can do as much science as we like, but there's always going to be this gap between what we experience and what it experiences that is basically impassable. And Daniel emphasizes that that's true, because even with language, I can't ask a bat what it's like to be a bat. I can ask Daniel Kish what it's like to be Daniel Kish. But are we, even when we're using the same words, are we talking about the same thing, or are we talking past each other? I think that's core to the book, right? That there's always going to be an element of the unknown that requires an active effort of imagination to cross. And that is kind of uncrossable. You know, the glory in thinking about animal senses is not like peering into like the secrets of the universe. I think it's that you're attempting a task that is actually that actually can't be completely achieved, but you're making the effort nonetheless. And I think there's kind of wonder and glory in that.
Yeah, well, it's so cool about the book is that it gets you a little bit way down that road. You can never get there, but the book actually opens your eyes to thinking about it in an interesting way. And there's this new thing they call the Internet of Animals. Are you familiar with this? Where they basically are
Is that my Google history, I think?
But the idea is you attach sensors to various animals, like transplanted whales or birds or whatever, and like take an albatross where you can put a sensor on the albatross that shows you where it's been flying, and it'll fly around for a couple of months, and it'll dip and feed on the water as it's going, and as it's flying, its wings are growing, and so the wings are being constructed out of what it's eating, and so when it flies back to the roost and you get it and you take a feather, you can actually see where it's been, but you can also see what it's been eating by looking at the isotopes in its feathers.
Right, yeah.
That's going to get more and more and more. There's more of these sensors on animals, and so to some degree we're going to start watching the world of animals play out in a way we've never seen them before, and I imagine there's going to be some insights that get back to how they see the world from that kind of approach. I gotta say, I love the bat section the most, maybe because I love bats, and just the detail you put into the bat section about how they zero in on their prey and they increase the rate of things, and they zero in, the poor little bug has to get out a chance, basically. But I'm a paleontologist by training, and we know that bats sort of appear pretty rapidly in the fossil record around 56 million years ago. There's a beautiful fossil bat from Wyoming, nearly perfect thing that is like a nearly fully formed bat, so they don't live much before that. So imagine how an animal evolves, and all of these things are evolved traits and behaviors based on something that was happening to their ancestors and the world they were in.
Yeah, and right, so echolocation is such an advanced skill that it is hard to think about how everything necessary for it came into being. You know, like an echolocating bat has to do a lot of things, right? Like, just think about it. So sound loses energy very quickly in the air. So to create a call loud enough to travel from a bat to an insect and then bounce back, it has to be really loud. And so a lot of bats absolutely scream. Like if we could hear those frequencies, they would be actually quite painful. They can be like jet engine loud. How then does the bat, which can hear its own calls, avoid deafening itself? It has a special setup where it basically switches off its own hearing in time with every call and then puts it back into place when the echo comes back. And it's doing this up to like 200 times a second. That's ridiculous. And yet it occurs, right? Now you might think then, how does something like that happen? But there are a lot of animals that do a much simpler form of echolocation. I mean, humans obviously are one of them, but other creatures too. Like there are these weird cave-dwelling birds called oil birds. A group of mice, I think, sometime during the pandemic were revealed to also possibly be echolocators. There's quite a lot of creatures that probably do this, but no one would know that they do it unless they recognize that echolocation is a possibility at all. And this is, I think, one of the wonderful things about studying the senses. Like, our senses close us off to these other worlds, to these abilities that animals have. And every time you push against that barrier, you open up the possibility for more discoveries. So the fact that Donald Griffin and others showed that echolocation exists in bats in the 1940s then allowed scientists to look for the same ability in other animals, and lo and behold, dolphins have it. And once you know that bats can echolocate, it becomes much easier to try and work out that dolphins and other creatures do it. Similarly, once people realized that robins could sense the Earth's magnetic field in, again, like the mid-20th century, they could start looking for the same ability in other creatures. Don Griffin, the bat echolocation guy, talked about echolocation as being this sort of magic well, you know, that from which you could endlessly draw new, amazing insights. And yeah, I think that's one of the things that I love about this area, and one of the things I hope that the book does too, to people who are interested in sort of going into this space. You know, I think I talked about the importance of these active feats of imagination. I think that's true for researchers in this field as well as for everyone else.
Yeah, the one that really sticks with me too is the story of the big whales, the ones that can sing across entire oceans, or in theory, and that's, you know, I guess I'll make a point here that I came into the book with the impression that some animals, we did know why some animals responded to the magnetic field, and I left the book thinking, oh, we don't really know why they do. But it's a little bit better known, the story of the great whales and their low frequency calls that can go for thousands of miles. Yeah. So Roger Payne and some of his and some colleagues of his did these calculations in the 70s showing that big whales like blues and fins can make these very deep infrasonic calls that travel over vast distances in the water, oceanic distances. And he was like ridiculed for this idea. You know, people just didn't buy it. And then once scientists had access to like Navy hydrophones, they realized that, no, you absolutely can hear a whale that's calling off the coast of Europe from the coast of America.
Now, there's an open question then about whether the whales themselves do this, right? Are whales like listening into each other's calls over those distances? We know the calls can travel over those distances. Are they actually being used for communication? It's really hard to answer that question, especially for an animal as big and as elusive and as hard to work with as a blue whale, the largest animal that has ever existed, right? So how do you prove the hypothesis? I think it's really hard, but at least I think there's something magical about even the possibility of it. And it makes you think, like, even if we're not talking about oceanic scales, right? Even the idea that great whales can communicate over huge distances, it changes your understanding of what these animals are like. Like, what is a whale pod? Like, if you saw one blue whale swimming alone in the ocean, is it alone? Or is it in acoustic contact with other whales far, far away that you can't see? So we would define a group based on something that is visually coherent, some animals that appear visually next to each other, because that's the sense that we're prioritizing. But if you think about sound, then a group doesn't have to be animals like swimming like this. And I think that's one of the... There are lots of concepts that I think change radically when you think about the Umwelt concept.
You're able to really, I mean, you had a lot of fun with this, clearly, because you're able to stretch metaphors that are usually one for one sense and wrap them around other senses. And there's many little side things in the book when you talk about hearing with your eye, or various things where you're like mixing up the metaphors. I want to get back to eyes too, because I'm so used to having two eyes that I can't imagine having a lot more eyes.
Yeah.
But it turns out a lot of things do have a lot of eyes.
A lot of eyes. I think, so the vision chapter was actually quite difficult to write because, a lot of people, I mean, not everyone has sight, but for those who do, it is a very important, very primary sense. And yet, as you say, sight still manifests in very, very different ways in other creatures. We are quite unusual in that we have two eyes, they're both forward-facing, they're both on our head. None of these things need to be true in other animals. Starfish have eyes at the tips of their arms. Scallops have rows of eyes, up to a few hundred, around the edges of their shells. There are, eyes come in such an immense variety. And that's just like the number and location, right? Then there's ways of distributing functions that we all have in just our two eyes across different eyes. So jumping spiders have 4 pairs of eyes, 2 pairs face forward. So there's 2 big ones in the middle and then 2 small ones on the side. The big ones in the middle do acute vision and probably color. The ones just on the right, on the side of them, do movement. So if you block those 2 eyes, the spider can't track an object moving in front of it, which is so weird, because I track movement and do color and do focus vision with my eyes, because I only have 2. But if you have more, then you can distribute the labor among different organs. And how does that work? I have no idea. It also gets weirder when you think about the creatures that have very simple nervous systems. So I said a scallop has dozens of eyes around its shell. Does that mean that it has this beautiful wraparound image? Like, could it see like all of you here, but also like the signer to the side, or like Kirk? Probably not. It seems its nervous system is incredibly simple. Its brain is very simple. It's one of the scientists I talked to, Daniel Spicer, who studies scallops, was saying that his view is that probably the information that the eyes give to the animal's brain is incredibly simple. It's not an image, it's more just something is happening here in this part of space. And that kind of seeing without scenes is also, I mean, it's basically unimaginable. I don't know what it's like to imagine it. The metaphor I use in the book is that imagine you have a security guard with a bank of monitors in front of them. Each monitor is connected to an actually pretty good camera a motion-sensitive camera. But the camera isn't actually feeding any images to the monitor. It's just saying something is happening here. You should pay attention to like your 5 o'clock. That seems to be what the experience might be like. But again, I really struggle to get, and it's ironic, I really struggle to get my mind to imagine what a scallop might be experiencing. And I don't think that I'd ever in my life thought that I would be really struggling to empathize with a scallop, but here we are.
Well, many of us 2 years ago saw this film called My Octopus Teacher,
Right.
which was an odd film to say the least, an interesting film. But you kind of run aground on the octopus, don't you? I mean, he's such a different kind of beast, these cephalopods, and it seemed like at that point it was like you were struggling to catch various organisms, umwelts, and then you got to this one, and it's like, well, wait a minute, this is a different situation altogether.
Yeah, right. So the octopus appears in the penultimate chapter, which is how we bring information from all of our senses together. And there's a lot of literature, a lot of mythology about people being able to like transfer their consciousness into another animal. I'm often asked, like, if you could inhabit the umwelt of another creature, what would you pick? I think the point of that, the octopus section, is to say that that wouldn't work because our experience of the world is heavily influenced, completely influenced by our senses, the way our nervous system works, the way our bodies work. So it's not just that the octopus is a different umwelt. It's not just that it is sensing different kinds of things. It's also that it is that putting all that information together in completely different ways. An octopus has more neurons in its arms than in its central head. And those arms have a degree of autonomy to them. They can do things and perform actions like reaching out and bringing objects in without actually requiring control from the brain or even really needing to bother it. It's definitely crosstalk between the two, but there's also a certain degree of independence. So you have this animal with like a head that has an umwelt that is connected to its 2 very good eyes. The rest of the body has its umwelt that is dominated by taste and touch. And there's some connection between those two, but it's not the same as what we have. It's a completely different kind of organization. And it's really hard then to think about the kind of consciousness that results from that. There's so many stories about like octopuses displaying their intelligence by finding a crab in a jar and unscrewing it and taking the crab out. Like, to what extent is that intelligence as we know it? Because here is a creature where, like, if the arms can act relatively independently, and if they're doing their own little explorations, then is that a sign of like problem solving, or is that the sign of the arms just kind of going ham on this this new thing? I think it's really hard to say. And I think part of the argument here is that everyone's really fascinated by these big questions about consciousness and intelligence and so on. The senses are like the first step of that, right? They are the basic. They give all the information that feeds into the rest of it, and we often forget that. We're often not thinking about that first step, and even at that first step, there's so much variety across the animal kingdom.
And what I've managed to do is hog all of the time with Ed for myself and not leave a moment for the Q&A, because I think it's a rare opportunity to talk to Ed, who is clearly one of the finest science writers writing at the present time. And I urge you all to purchase his book. He's signing at 6:30 tonight. And it's been a real pleasure to be up here on the stage and to chat with Ed and to see all of you. I want to thank also all the people that helped make this happen. It's been an amazing thing. And come again next year and go buy Ed's book and read it.